In this presentation and the following two, I'd like to subnet a network ID from start to finish. Here we have 172.20.0.0. It's class B, so therefore the default prefix is /16. The first two octets are network ID, the last two octets are host ID. I'd like to subnet this so that we get 6,000 IP addresses per subnet. Now, just as a quick reminder, subnetting is where you take bits from host ID and you're making it part of network ID. The bits that you took are called subnet bits. They determine the number of subnets you get, and the bits that are left over for host ID, and that determines the number of IP addresses you get per subnet. So here we want to subnet this to get 6,000 IP addresses per subnet. The way I'll tackle this problem is I'll actually start off by asking the following question. How many bits should I leave for host ID to get 6,000 IP addresses? If I can figure that out, then what will happen is I'll leave those bits for host ID, and the bits in front of it are the ones I'll take for network ID. Those bits will become the subnet bits. Let's recall the formula 2 to the power of h minus 2, where h is the number of host ID bits. This will determine how many IP addresses I get with h host bits. So the formula I'm trying to solve here, if I were to turn this into an algebra equation, is 2 to the power of h minus 2 has to be greater than or equal to 6,000. What is h? We're trying to solve for h. I'll solve for h by simply working out different combinations of h. Let's start off by trying h is 10. 2 to the power of 10 minus 2 is 1,022. We need 6,000 IPs, so that's not enough. Now we know if we add one bit to host ID, that's going to double the number of IP addresses we get. So if I were to take 11 bits, that would give me about 2,000 IPs. If I were to take 12 bits, that would give me 4,000. And if I were to take 13 bits, that would give me 8,000. So let's try those. H is 12. 2 to the 12 minus 2 is 4,094. H is 13 is 2 to the power of 13 minus 2, which is equal to 8,190. When h is 10, the number of IPs we get is 1,000. When it's 11, it's twice as many. When it's 12, it's 4,000. When it's 13, it's 8,000. Therefore, we need to leave 13 bits for host ID. So h here is 13. We need to leave the last 13 bits for host ID. This is 8, 9, 10, 11, 12, 13. These are 13 host ID bits. So therefore, what we can take for network ID are these 3 bits in front of it. These are the subnet bits. How do you take these bits? Well, you take it with a new prefix. The original prefix was /16, /16, 17, 18, 19. We need a new prefix of /19. With /19, these 3 bits become the subnet bits. The last 13 bits remain host ID bits. We will therefore get 2 to the power of 3 subnets. 2 to the power of 3 is 8 subnets. And 2 to the power of 32 minus 19, which is 13, minus 2 will give us 8,190 IP addresses. So we started off by asking ourselves this question. How many bits should I leave for host ID to get 6,000 IP addresses? And here we've calculated that we need to leave 13 bits. That therefore means we take 3 bits for network ID, and the way we do that is with our new prefix of /19. Calculating this prefix is the first thing that you do when subnetting a network ID. If you calculate this prefix incorrectly, then every single thing that we do thereafter will be wrong.